Welcome back, folks. We are taking a look at 4-1 standard form of a quadratic equation, which is this guy. Quadratic indicates that the highest power of x is a2, and this is considered standard form, where a is the coefficient of the x squared term. The a is going to be a key feature as we move forward. B is the coefficient of the x, and c is the constant. So parabolas mirror a lot of things in real life. Unfortunately, these are the things that Miss Myers chose to put on here. The dolphins are okay. The dog, not so much. Alrighty, let's have at it. So first of all, when you graph an ax squared plus bx plus c, you get a parabola, whereas we've been graphing mx plus b, which always makes a line. So we did linear equations. Now we're doing quadratic equations. So a parabola looks like this U over here on the right. It'll open up or down, and you can tell that by using your eyeballs. It will open up if you have a positive a, and it will open down if you have a negative a. So this particular one must have a positive ax squared in the function because it opens upward. The line of symmetry, axis or line of symmetry. So you'll see it on worksheets as like AOS, either as AOS or maybe LOS, and that just means axis or line of symmetry. That is always a vertical line, and it comes right down the middle, thus the name line of symmetry. And the favorite thing to do wrong on the next test or quiz is to not write that as a vertical line equation. If you think back to the previous chapters, vertical lines cross only the x-axis, and therefore they have x equals, and then all you have to do is tell where it crosses. Well, since it always has to go through the x coordinate of your vertex, it's going to be whatever the number is of this particular spot, which has an x coordinate for your vertex and a y coordinate for your vertex. So once you know that x coordinate, this will be x equals, and then whatever number is in the x spot of that vertex. So how do you find the vertex? I know you're wondering, so I'm going to tell you. To find the x coordinate, you're going to take the opposite of your b value from up in this equation and divide it by 2 times your a value from up in the original equation. So you're going to calculate that by taking opposite of b over 2a, reduce that to the smallest possible value. And then, like you have done since the beginning of math time, when you have the x but need the y, you simply plug in your x value. So you just found that the x value is whatever it's going to be. You plug it into your original equation, and it will kick out your y value. So we'll do that with some number examples that will hopefully make it a little easier. On this particular problem, let's just keep going. I'll go to that in a sec. Sorry. The y-intercept, that's going to be where it crosses the y-axis. Just like we had in a line equation, y equals mx plus b, the b was where it crossed the y. Keeping in mind that the only way you can be on the y-axis, which is right here, is if your initial x value is a 0. So you're plugging 0 into that equation, but if you do that, it's going to cancel out or eliminate both of these because they'll become literally 0. So you end up with 0 and then this c value as the place that it's going to cross the y-axis. So you can find this with no math. You can find this by doing opposite of b over 2a, but then you can find the line of symmetry with no math by just stealing that x coordinate. So you won't be doing a ton of math. It's just a matter of remembering which values tell you what things. Now, the x-intercept, and the reason this says sometimes is that it would be possible for me to have a parabola that doesn't actually have any x-intercepts or doesn't cross the x-axis. So that's why it says sometimes. Now, the terminology related to x-intercepts changes. You're going to see probably most often the term zeros. You'll be asked for solutions. In the old days, back in my day, we used to call them roots or x-intercepts. All of those terms are mathematically interchangeable. So whatever you're asked for, they all mean the same thing. And that is going to simply be exactly what it says, where it crosses the x-axis. And we'll work on how to find that as we make our way through this chapter. So let's take a quick look at this particular problem and give those features. So if you had this problem and you were supposed to find the vertex, then you would say, okay, the vertex of this is at 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2, -9 is the vertex. That's that point, which in this case is a minimum because it opens up. Then you would be asked to find your y-intercept, perhaps. Okay, well, that's where it crosses the y-axis, which is right here at 0, -5. If you're asked for your roots or your zeros, I'm going to write zeros actually because that's the thing that you're going to probably see the most often. The zeros in this case are here and here. So you would have a 0 at x equals -1 and x equals 5. Those are the two places that it crosses the x-axis. So those are kind of the features or characteristics of a graph, and you'll be asked to know how to find those either by looking at the graph or by using these approaches to doing it mathematically. Let's take a look at a few. Starting with the parent function. The parent function means what it looks like before you do any changes whatsoever. So if you are trying to figure out what this looks like in its most basic form, you would plug in a couple of numbers maybe, and when you square them, you would get out your y values. And then if you plot -2, 1, 2, 3, 4, -1, 1, if you plug those points into your graph and then connect them knowing that they have to make a parabola, you get what is considered the parent graph, the most basic one. So keep in mind that this is a 1x squared. So A is 1, but B is 0, and C is 0. So if you went down our list to find the vertex mathematically, you would have had to take the opposite of B over 2 times A. So you would have gotten a 0 for the x coordinate. Then you'd have to plug it into the function, which is x squared, to get your y. So that would be another way to determine that that's the vertex. Keep in mind that means that my axis of symmetry would be coming right down here through the middle. So my axis of symmetry would be x equals, and then I just use the x coordinate because it has to go through that point. So then in this case, the only solution, zeros or x-intercepts, is the point 0, 0, because that's the only place this graph touches the x-axis since it's sitting on it. But that's the parent function. Let's look at one that has a little more going on. So the first thing and the best thing to do is identify what your A, B, and C values equal. So in this case, I'm looking at 2, -8, and 6. So to find my vertex, I start by doing the x coordinate. I'm going to take the opposite of my B, so the opposite of a -8, over 2 times my A. So I end up with 8 over 4. So with 8 over 4, the negatives canceled, I end up with an x coordinate of 2 for my vertex. To find out where the y coordinate is, I would go back to that original equation, and I'm going to plug in that 2. So I'm looking at this original function, and I'm plugging in my 2. And that is going to kick out a -2. So now I know my vertex is at +2, -2. So there is my vertex. Okay, that's a really key point. That also will tell me my axis of symmetry. So I can think, okay, my axis of symmetry or line of symmetry is going to be x equals whatever the x coordinate of my vertex was, because in order to actually go through it, my vertical line of symmetry has to go right through that vertex and have the same x value. So that's my axis or line of symmetry. Then if I want to try to figure out where are my y-intercepts, keep in mind that one's pretty easy because the y-intercept is simply from our notes 0 and then the c value, because these would cancel out if I plugged in zeros. So I know that at 0, 1, 2, 3, 4, 5, 6, and then what I like to do is put a mirror buddy point on the other side, which helps me graph this. So if that was 2 to the left, then 2 to the right would be another point that went up 6. So I found my vertex, I found my y-intercepts, I found my axis of symmetry. My x-intercepts are going to be a little bit tricky to find. And what we're going to be doing later on is we're going to learn to find them using factoring. So I don't know how confident you feel about factoring at this point. But if I'm just going to go ahead and show you because I think some of you will remember and the rest can learn it over time. If I was to factor this problem, I'm going to have to make some space. I'd pull out a 2, leaving me with x squared minus 4x plus 3. I'd be trying to get that to equal 0 so that it'll be on this 0 line. Then I'd factor this part because I can't make 2 into 0 because it's 2. To get 3 on the end in a way that adds up to 4, I'll do 3 times 1. And then to get a negative 4, they'd both have to be negative. Negative 1 and a negative 3 would make negative 4. But I'm looking for what makes those equal 0. So the thing that would make x minus 1 equal 0 is if x equaled 1. The thing that would make x minus 3 equal 0 is if x equals 3. So then that's going to give me my 2x coordinates, my 2x intercepts. So even if I didn't know how to find those because of these y-intercepts and its buddy and the vertex, I would have been able to draw a pretty good graph of this. And I can see this one's a little skinnier than my parent graph. That's because my number 2 in the front is a bigger number. As that number gets bigger, my graph gets skinnier. So that's how you kind of walk through to find those. So if you feel like you can do this from here on out, you can go ahead and try the worksheet and the homework. But otherwise, if you want to watch through a couple more examples, I will show you how to do that. So, okay, I'm just going to go right straight through here. I'm going to start by identifying A, B, and C. I'm going to find my x coordinate by doing the opposite of B over 2 times A, so I end up at a 3. To find my y coordinate, I'm going to plug that 3 in. Now be careful, this goes back to chapter 1 when we did PEMDAS and parentheses and negatives. I'm plugging in a positive 3, squaring it, and then the negatives out front. It's not a negative 3 that's being squared. It's the negative and then just the 3 that's being squared. So when I do that, that comes out to be a 1, becomes my y coordinate. So at 1, 2, 3, 1, I have my vertex. Looking at my a value, which is negative, I'm expecting my parabola to open down. So if it doesn't, then something's not quite right. Let's see, another easy thing to find would be my axis of symmetry. So my line of symmetry, axis of symmetry is going to be x equals the x coordinate of my vertex. So that line would be coming right down here at x equals 3. Keeping in mind I need to write it as a vertical line with the x equals part. Something else that's easy to find will be my y-intercept, because my y-intercept is 0 and then the c value. So at 0, negative 1, 2, 3, 4, 5, 6, 7, 8. And then I'm 3 over from my line of symmetry. So 3 over on the other side, I'm going to get some points as well. And then I'm going to cheat and kind of look ahead like I showed you last time. I'm going to pull out a negative from this to make it easier to factor. But that'll change this to a positive, this to a negative, and the 8 to a positive. Then I can ignore the negative because you can't make negative 0, so I'm not interested in that. I'm only interested in the parts that I can make equal 0. To get 8 in a way that adds up to 6, I'm going to have to do 4 times 2. And to get a negative 6 out of that, they'll both have to be negative. Which means that in order for those to equal 0, I would need a 2 to make this one 0. And I would need a 4 to make this one 0. So at 1, 2, 3, 4, I have my x-intercepts. And that again is getting a little bit ahead, so you might find some that don't factor easily, and so then you just sketch it the best you can with whatever points you have. But you're smarty pants, so I figured I might as well show it to you now. Okay, so this next one ends up really nasty in terms of the size, so we're just going to scratch that, literally. Okay, bye-bye, bad example. So this one doesn't give us graphing anymore, and a lot of times we aren't going to really use graphs with our quadratics. We're going to be using them to apply to real life situations, and so we don't want to have to graph the function every time. That's not the most efficient way. So this wants to know if it has a minimum value or a maximum value. So that's pretty easy to think about, because if I had a positive a, it'll open up and the vertex will be a minimum. If I have a negative a, it'll open down and the vertex will be a maximum. So when I look at this problem, it has a positive a value of 3. So that means it's going to open up. So that means that this one's going to have a vertex that is a minimum. So in terms of the first part of this problem, tell whether it has a minimum value or a maximum value, we're looking at a minimum. Now, then it asks you to find the minimum value. Keep in mind that when it's asking you the value, it actually wants to know how low does it actually go or how high if it's a max. And so in order to tell that, you need to use the y value of the vertex. So when we get to word problems, students make them a lot harder than it really is because it's almost always asking you about the vertex, either the x or the y coordinate. So we can't find that y coordinate without the x coordinate, because to find the y coordinate, we have to plug in the x, which we don't know. So I go back to finding the x coordinate by taking the opposite of my b, which is this guy, over 2 times my a, which was this guy. So I end up with 18 over 6, so 3, which is not even a part of my answer. It's just a part of getting my answer. So then to find the answer to the question, which is to find the minimum value, I would go back to my function and plug in the 3 that I got as an x value, just like we did on all the previous problems. So when I do that, it kicks out a -7, which means if I graphed this at 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, that would be the value. This is a positive, so it would open up. So that -7 qualifies as the min value because it is the lowest spot on the graph. The 3 is not the lowest spot. That's just locating it. You're saying go over 3 and down 7. So -7 would be the lowest spot. So keep that in mind, that when they ask you for the value of something, they're talking about the y part. So work your way through this one, then just peek and see if you and I get the same thing. So this one's going to have a max. It doesn't matter whether it's min or max. I'm still looking for the y coordinate, which I can't get to until I find the opposite of b over 2 times a, so that's this. Not interested in that number, however, except to plug it in. Now be really careful. Again, this goes back to all the tricky bits from chapter 1 of really paying attention to those negative signs. What I get is this. And so that is going to be my my max value. Because what I know, if I think about this, is that it has a vertex of -1, -4, but the a value is negative, so it opens down from there. So that -4 is the highest it ever goes, making -4 the max value. Okay, I think we're going to quit right there. I'm going to make this a different day, and we'll do applications on a separate video. Have a great day, you guys.